Hello guys, today we're gonna learn about Wireshark and Packets Operations, how those work. We're gonna search, we're gonna filter using this tool Wireshark. Okay, so before this we're gonna first find out what are those tables here. And first we got resolved addresses. This option helps analysts identify IP addresses and DNS names available in the capture file by providing the list of the resolved addresses and their host names. That's it. So providing the list of the resolved addresses and host names as well as IP and DNS. Next we got a protocol hierarchy. This option breaks down all available protocols from the capture file and helps analysts view the protocols in a tree view based on packet counters and percentage. So here we go, we got this here. Next one, we got conversations. Conversation represent traffic between two specific endpoints. This option provides the list of conversation in 5 base formats: Ethernet, IPv4, IPv6, TCP, and UDP. Okay, endpoints, which is similar to the conversation option. The only difference is that this option provides unique information for a single information field. Ethernet, IPv4, IPv6, and so on. Thus, analysts can identify the unique endpoints in the capture file and use it for the event of interest. Next one, we got endpoints. It looks like here, like this. And then we got name resolution is not limited only to MAC addresses. Wireshark provides IP and port name resolution options as well. However, these options are not enabled by default. If you want to use these functionalities, you need to activate them through Edit Preference Name Resolution menu. Once you enable IP address and port name resolution, you will see the resolved IP addresses and port names in the packet list pane, and also will able to view resolved names in the conversation endpoints minutes as well. Okay, name resolution, transport. Okay, and then we got, so we put in preferences, we put name resolution and tick those two, resolve transport names and resolve network IP address. We press OK and it gives us IP and port name resolution, like here we see. Okay, we got some more new options too. We can, for example, Wireshark can provide us IP geolocation mapping, and that helps analysts identify the map source and destination addresses. Like here we see. But it's not gonna work on the lab because it's because the lab is in the will not have internet connection. So let's wait a little bit for this to work, and let's focus on what are the questions here we need to answer here. So investigate the resolved addresses. What is the IP address of the host name? It starts with BBC. Okay, we got the machine open. Resolved addresses can help. We got a clue. Okay. Resolved addresses tab. We need to look for this. Okay, so we got this packet file open in a Wireshark. And we need to look for, investigate the resolved addresses. What is the IP address of the host name? Starts with BBC. Okay. Okay, so how can we check this? So here it was like, there was a lot of tabs. Statistics. We need to go to the statistics here. Resolved addresses. Okay, hosts, and we need to look for BBC hostname. IP address of the hostname starts with BBC. BBC map fastlynet. This is the IP address 199.232.24.81. Okay. What is the number of IPv4 conversations? Conversations can help. Okay, let's do statistics, conversations, IPv4. So we got IPv4 435 right here. 435. How many bytes were transferred from the micro ST MAC address? Endpoints and name resolution can help. Statistics, endpoints. How many bytes were transferred from the micro ST MAC addresses? We got bytes here. We got MAC addresses here. But we need this micro ST name resolutions. I put name resolutions here. And we need to look for the micro ST. Yeah, here we go, micro ST. And we got 7474. 7474. What is the number of IP addresses linked with Kansas City? Okay, endpoints can help. So we are in endpoints. And how can we check the location here? here we go. Here we got the locations in IPv4. Let's check another country TCP. So what is the number of IP addresses linked with Kansas City? So it's here in countries. So let's take a look at. So it must be United States, Germany, Hong Kong, Japan, Netherlands, Poland, Russia, United Kingdom, United States. Here we go, four Kansas City's IP addresses, 3 and 4. Which IP address is linked with BlickNet as organization? BlickNet. So let's check the resolutions, name the resolutions. Again, just checking that, and let's find it, BlickNet. Which IP address is linked with BlickNet? So it must be here. You can't put name resolution in IPv4 as organization. What is that AS organization? Let's check here. No, here I can't. I need to find it here in IP. There you go, we got the IC organization. So it's on the end of this table, on the last column, and let's find it. It's BlickNet. BlickNet though, right here. It's 188.246.82 and 7. Okay. Statistics. So let's read through it. IPv4 and IPv6. Up to here, almost all options provided information that contained both versions of the IP addresses. The statistics menu has two options for narrowing the statistics on packets containing a specific IP version. Thus, an analyst can identify and list all events linked to a specific IP version in a single window and use it for the event of interest. So we can from statistics we go IPv4 and we got all addresses, and we have all addresses here. We can put destination and ports, which gonna display all destinations and ports, and also TCP, UDP, and next we got IP protocol types. which is the UDP TCP or none. And when we put source and destination addresses, we're gonna find out all the IP4 addresses and so on. So plenty of information here. This DNS, this option breaks down all DNS packets from capture file and helps analysts view the findings in a tree view based on packet counters and percentages of the DNS protocol. Thus, the analyst can view the DNS service overall usage, including error opcode, class, query type, service, and query stats, and use for the event of interest. You can use the statistics DNS menu to view this info. Okay, so we put DNS, we got all informations about name resolutions. Packet counters and percentage of DNS protocols. Those are the percentages of the port protocols, so we know which one was used the most. Okay, next one, you got HTTP, and this option breaks down all HTTP packets from the capture file and helps analysts view the findings in a tree view based on packet counters and percentage of HTTP protocol. Thus, analysts can view the HTTP service overall usage, including request and response codes and original requests. You can use statistics HTTP menu on this view. So we got HTTP view, and four options: packet counter, request, load distribution, request sentence, and each gonna show us some bit of information. Okay, so when we put the packet counter, we're gonna see like lists of all the packets from HTTP protocol, requests, all HTTP requests, load distribution, which is this in here, and request sequences, which is this. Okay, so let's do it in the questions. Let's open our let's open our our machine, and let's do it. What is the most used IP4 addresses? What is the most used IPv4 destination address? IPv4 statistics can help. So let's close this one. Statistics and IPv4 statistics. All addresses. What is the most used one? It says it's this one. Count 58. And what is the... No, it's not that one. What is the most used IPv4 destination address? Okay, let's open statistics again. IPv4 statistics. And let's put destination and ports. Yeah, so here we go. Destination and ports. Count. there's a lot of it, so that's why we need to filter all of this. I'll just make them sorted out. So we got those two addresses that has the most, and here we got 29,387. So this IP address has the most destinations. So we know where most of the traffic went, and it's these addresses. Okay, let's go for the next one. What is the max service request response time of DNS packets? So I guess we need to go to the DNS statistics. So what they wanted to do, DNS, we put DNS, and what is the max service request response time? Service request response time. Okay, so we need to know how long the DNS packets were sent. Average count, total packets 171. There's not a lot of it. Let's put it here like that, and we can actually see all of them. Max and minimal value, average, payload size, total packets, max value, there you go, you got request response time, seconds, and minimal value is the 0.0075 and the max value is 0.46. So what is the max service request response time of DNS? It's 0.467897. So this value here. What is the number of HTTP requests accomplished by radmsn.com? Let's check HTTP statistics. HTTP, and they want us to check the requests and what is the number of HTTP requests accomplished by radmsn.com. So this address here is defunct, so that I wouldn't click on it just by accident. So they just secure that for me. So I will not just accidentally just go into it. And let's check where I can find this address. Let's rad.msn.com. Have something here? No. Okay, so let's put it in a big view. So what is the number of HTTP requests of RAD MSN? I think we need to check it like this, there's not a lot of it, so we can just check it like that without filler. social MSN resource radmsn.com. Here we go, and we got pretty a lot of it. 2, 4, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 14, 16, 18. 19. I'm sorry. No, it's not 19. 2, 4, 6, 7, 8, 9, 10, 12, 14, 16, 18. 18. It's not 18. msn.com. What is the number of HTTP requests? I don't need that. I don't need this. So what do they want here? Maybe there are more later, but no, I think it's just that one and that's it. And here there are I read msn.com, but it's different. radmsn.com. radmsn.com. Let's check 20. No, it's 20, it's not. Also, it's not that one. Let's check 17. No. Okay, let's radmsn.com. Does it show us something? No. Maybe HTTP requests. No. What is the number of HTTP requests accomplished? Accomplished. So the word accomplished here so this is, what is AP? Accomplished packets. Let's ask ChatGPT. What what AP means. AP means here. Access point. AP, the values AP look more like internal numeric IDs and readable settings. I ask which are the accomplished packets. It's not there. So maybe those are 3, 6, 7, 8. But still, let me try 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Why 18 doesn't work? Maybe 14, maybe 15. I don't know, 2, 1, 2, 2. No. So let me, if it's maybe it's more than 20. RAD, what is the number of HTTP requests of radmsn.com? It should be 18. RAD MSN, MSN Microsoft. No, no, no. Let's ask Google. Is 39. Why 39? What is the number of HTTP requests accomplished by radmsn.com? Answer 39. Statistics HTTP. Yeah, I did that. Look for the domain name and scroll all the way to the right. They hid somewhere around here on the right side. There you go. So wait, msn.com, it's 39. So here we got this packets, but I counted it. It's not 39, but maybe there are some hidden there. So 39 is the answer. Okay, so for now we finish it, and for now I'm gonna do a part 2 in this. So yeah.